Bismillahirrahmanirrahim. Assalamu alaikum, boys and girls. Welcome back to another new lesson of distance learning program. My dear students, boys and girls, we have been discussing this topic called trigonometry. Today, again, we will be continuing with the same topic and we will be doing some word problems, that is, the application of trigonometry in the real life or real world context. So, let's start our regular lesson, boys and girls. So, my dear students, this is your maths instructor, Sayyid Faraz Hassan. With me, I have my team, the team of subject specialists, Sir Ashraf Ali and Miss Shabana Salman. My dear students, this is the topic called trigonometric ratios. This is chapter number 11 from your maths book 2. Okay. What we have discussed so far, my dear students, we have discussed about right angle triangles, and we apply the SOHCAHTOA techniques to find out the unknown sides and angles in the right angle triangle. Excuse me. And remember, whenever we are asked to find the unknown sides, we simply applied sin, cos, tan, that is sine, cosine, and tangent. And whenever we are asked to find the unknown angle, what do? We apply sine inverse, cos inverse, and tangent inverse with a function called a fraction function that is also a built-in function in your calculator. So if I wanted to let's suppose if I wanted to calculate an angle A, what I'm going to do, tangent of angle A equals to whatever it is, to a opposite upon adjacent. Now, I wanted to calculate the value of angle A. What I'm going to do, I'm going to move this tangent over there. When tangent moves there, tangent becomes tangent inverse. Then I need to write the value of opposite and adjacent. I'm going to use a function which is a box upon box function. I told you earlier, you can plug in the value of numerator and denominator, press the equal sign, and finally you'll get the answer in degrees. All right, boys and girls, this is how you do it. So uh, let's have a quick recap. Boys and girls, trigonometry is used to measure the height of a tree. Remember, if we have done a question last time. If I wanted to calculate the height of the tree, we can apply trigonometrical technique to find that. Trigonometry is used in measuring the height of a building or a mountain, and trigonometry is also used in aviation. What is aviation? It's related to the radar system, that is the surveillance of the aircraft. So trigonometry is used uh, everywhere. It has a lot of application in our real lives. So you can Google it for more information, boys and girls. Our learning objective for today, we will be able to apply trigonometrical ratios in real world context. Okay, this is exercise 11D from your maths book 2, question number 5. A ladder of length 5 meters leans against a nail on a vertical wall. It forms an angle of 60 degrees with the horizontal ground. Find the height of the nail above the ground. Find the distance of the foot of the ladder from the base of the wall. So, boys and girls, for a better understanding, always try to make your own figure. Okay? The figure gives you the clear picture and understanding of the question. What are they asking about now? They're talking about a wall. So let's make a wall. This is our wall. Now, a ladder of length 5 meter leans against a nail on a vertical wall. Let's suppose this is a vertical wall. Here is a nail somewhere over here. Okay. Now, if this is a wall, so there has to be a vertical ground, horizontal ground. So this is our horizontal ground. Okay. A ladder of length 5 meters leans against a nail on a vertical wall. A ladder is placed something like this. Okay. This is our ladder. And these are the steps of the ladder. I hope this makes sense to you guys. Okay, the length of the ladder is 5 meters. And here is a 90-degree angle between the wall and the ground. We know that. Now, it forms an angle of 60 degrees with the ground. So let's make this 60 degrees angle, boys and girls. Now, find the height of the nail above the ground. Let the height of the nail above the ground be h. Let's suppose it's h. We need to calculate h. The distance of the foot of the ladder from the base of the wall. So we need to calculate this distance d. Let it be d. So what? Let us suppose the horizontal distance be d and the vertical length, the height of the nail above the ground is h. So boys and girls, here is the triangle, a simple triangle that gives you an acute angle 60 degrees, the hypotenuse length 5 meters, and what are they asking you? The opposite side, that is the height of the wall, and the adjacent side, the distance of the base of the ladder from the wall. Okay, so first thing, in order to calculate the height of the wall, what do we need to have? We need to have the relation between the opposite and hypotenuse. Opposite and hypotenuse, they both come in sine. So I can use a so function. Sine of the angle 60 degrees. Opposite is h. Hypotenuse is 5. Boys and girls, cross multiply this 5 over there. H equals to 5 multiplied by sine 60 degrees. So dear students, 5 multiplied by sine 60 degrees, your calculator will give you this answer, and it is found to be H is equals to 4.33 meters. This is again correct to 3 significant figures. This is our first answer, boys and girls. Part 2, the distance of the foot of the ladder from the base of the wall. I supposed it as d. So I need to calculate this horizontal distance d. So this is my adjacent side. So I'm going to apply cos of the angle 60 degrees equals to adjacent upon hypotenuse 5. Cross multiply 5 over there. D equals to 5 times cos 60 degrees. Please use your calculator to get this answer. 5 multiplied by cos 60 degrees. The answer is found to be 2.5 meters, boys and girls. Okay, dear student, hope this is quite clear. A very simple question. Only what you need to do, just make a simple figure for a better understanding. Hope you were able to do it. Now, this is question number 8. What are they asking us? They are asking the height of a building. Let me read it from a book. The height of a building, WH is 8 meters. PQR is a flagpole, and WH is the horizontal cable connected to the top of the building and to the flagpole. Given that PWQ is 35.4 degrees and angle WRH is 24.3 degrees, find the height of the flagpole. So boys and girls, the very first thing, they have given you the figure. You don't need to make your own figure. Just label the names, correct names. What they are saying, find the height of the flagpole. What is the flagpole? Flagpole is this. This is the flagpole, boys and girls. Now, the height of a building, WH. This is your building, boys and girls. Right? WQ is the horizontal cable connected to the top of the building to the flagpole. This is the cable, boys and girls, a cable wire that is connected between the pole and the top of the building. Given that PWQ 35.4 degrees, you can see it, it's here. And WRH is 24.3 degrees, it's here, boys and girls. Find the height of the flagpole. Now, boys and girls, the height of the flagpole is this vertical length RP or PR. Now, we can see that if you see the figure very carefully, the height of the building is WH and it's 8 meters. So I can plug in this 8 meters over here also. This is also my height of the building. So my flagpole length, PR equals to, that is 8 plus PQ, right? This is a simple formula to calculate the height of the flagpole. I got 8 meters from the building, that is a rectangle. You can see a bottom figure, a rectangle. So both the parallel sides are 8 meters. Now I need to calculate this much distance, that is PQ. So what I need to do, I need to use this triangle to calculate my opposite side. Now, in order to calculate this opposite side, what do I need? In the triangle, at least I need one side to calculate this, so that I can apply either so or ka or tua. As an acute angle is given 35.4 degrees, but there is no side given to us. It means we need to seek help from the bottom rectangle or a triangle shown to you. Okay? You use this triangle so that you can calculate the length of the cable, that is this, that is the length of the rectangle. You can calculate this. How are you going to do that? Because this is a rectangle, both the opposite sides are equal. You can calculate HR. If you consider this triangle WHR, I'm writing it here, in triangle WHR. Okay? Now, I need to calculate adjacent side. Opposite side is given to me. Adjacent and opposite, they both come into a, I'm using this tangent function. Tangent of this acute angle given to me 24.3 degrees is equals to opposite upon adjacent HR. Now, cross multiply HR over there. I'm doing it here. Cross multiply HR over there. Bring tangent 24.3 downwards. So you have, boys and girls, HR is equals to 8 upon tangent 24.3 degrees. Now, boys and girls, in your calculator, you have a button that is called a box upon box function. Use that function to get your answer. 8 divided by tangent 24.3. So let me use my calculator, and it is found to be 17.72 meters. All right, boys and girls, 8 divided by tangent 24.3, the answer is found to be 17.72 meters. Now, I found this. Now, remember, I told you this is a rectangle, the opposite sides are equal. It also means that WQ is also the same 17.72 meters. Okay, this is not our answer, boys and girls. Our answer is to calculate, the required thing is to calculate the height of the flagpole. In order to calculate the height of the flagpole, we need to calculate this much distance, that is PQ. Okay, and for this I told you we will be using this triangle, that is the triangle WQP. I'm writing it here again, in triangle W, Q, and P. As I got the height 17.72, I'm mentioning it here, 17.72 meters. So I'll be using this to calculate my opposite length. So again, I'll be using the same 2R function, TOA. Tangent of this acute angle given to me as 35.4 equals to opposite, that is PQ, upon 17.72. Cross multiplied there. PQ equals to 17.72 multiplied by tangent 35.4. So my dear students, your calculator will give you the correct answer. 17.72 multiplied by tangent 35.4, and the answer is found to be 12.59 meters. Still, this is not our answer, boys and girls. We'll get our answer from this. As I told you earlier, I'm writing it here again. So therefore, the height of the flagpole PR is equals to 8 plus 12.59. So 8 plus 12 gives you 20. So the required height is 20 point, we can correct it to three significant figures, 20.6 meters. That is the, it's PR, right? It's PR. That is the height of the flagpole. All right, boys and girls, hope the concept is clear. As I told you earlier, for a better understanding, try to make your own figure. But in this figure, the figure was already given to you and you have calculated it by using the same figure. Hope the concept is clear. Okay, let's do one more question, boys and girls. So dear students, this is question number 10. A pendulum of length 45 centimeters swings backward and forward from x to z, passing through y. What is y? The middle point of oscillation. The angle between the pendulum at x and z is 30 degrees. Find the height in which the pendulum bob rises above y. So boys and girls, they have given you a pendulum and they are telling you that it is swinging between the points x and z. Whereas the point y is the fixed point, okay, that is the middle point of the oscillation. The angle between the pendulum at x and z is 30 degrees. So this 30 degrees is the complete angle, boys and girls. Excuse me, this is it. This 30-degree angle is the complete angle, right? It's a big angle, 30 degrees, right? Okay, now find the height in which the pendulum bob rises. So first of all, boys and girls, you can see that we need to have a right angle triangle. Now, in order to have a right angle triangle, we'll break up this 30-degree angle into two parts like this. So this will become the half of 30 degrees is 15 degrees. All right, now this is the center point, and look at this. This is the center point, or I can say the horizontal line, the grounded line. Now the bob, you can see it, it is at a certain height over here. Can you see this height? Okay. Now if I try to make this triangle like this to show you how much it has gone up. Now look at this. Initially it was over here. The bob at y is at the lower end, and relatively the bob at point Z is relatively a bit higher. So they are asking you find the height in which the pendulum bob rises above y. Above y, if I can show you with another figure like this, okay, this is it. This is it. Now, this is a right angle triangle, right? Initially, the bob was somewhere over here. Okay, when it moved there, when it moved in this direction, it has raised to this height. Is that clear, boys and girls? Now, this much height has been raised upward. They're asking you calculate this height. Okay, now this angle is 15 degrees. Okay, this length is 45. Now, what about this length, boys and girls? That is the adjacent length. As I told you, this much is height h. So What will be this much length? It will be 45 minus h. 45 minus h. Okay. Now you can calculate the value of this h. How? Adjacent value is seen there in the figure. The hypotenuse value of the triangle is also shown you. So you can apply CAH, that is cos of the angle 15 degrees is equals to adjacent 45 minus h upon hypotenuse 45. Cross multiply 45 over there, boys and girls. So you have 45 multiplied by cos 15 degrees is equals to 45 minus h. Now your calculator will give you this much answer, boys and girls. 45 multiplied by cos 15. The answer is found to be 43.47 is equals to 45 minus h. What is unknown? H is unknown. Bring this h on this side and shift this 43.47 on the other side. So 45 minus 43.47. You can use your calculator, boys and girls, to get your answer. That is 45 minus 43.47. The answer is found to be 1.53 centimeters. So this much is the height or the length. The pendulum, the bob rises above y. This is the respective height. Hope the concept is clear. For a better understanding, you are advised to make your own figure and do the question once again. So, boys and girls, what we have learned today, we have learned how to apply trigonometrical ratios in real world context. Thank you. Always be thankful to Almighty Allah for all His blessings. Alhamdulillah. Uh, Attempt the homework right after this lesson for a better understanding. Leave a response and take a good care of yourself. Take a good care of everyone around you. We meet again next week. Have a nice day. Allah Hafiz.